So this video we're going to talk about the changes in electrolyte after the electrolysis and also some mismatch cases for the electrode. So first of all, for changes in electrolyte, okay, the skills is very easy. You have to check the ion table. So for example, when you got cation and anion, so in the process we find that some of them they react, like hydroxide ion reacts, discharge, hydrogen ion discharge. So in this case you find that okay, the water is getting less and less. So leaving behind you have more sodium chloride. So you find that in these cases, okay, the concentration of the sodium chloride solutions will then increase. So mainly the changes in the electrolyte will have two types. So the first one, like what we have mentioned, it will be related to the concentration of the solution. In some cases, the water will decrease. That means the water have consumed. So therefore the concentrations will then be getting higher. The other type will be the nature of nature of the electrolyte. So for example, this one is sodium chloride. In some cases, maybe okay, they will have just sodium and hydroxide left behind. So therefore, it will become sodium hydroxide instead of sodium chloride. So let's have a look. So for changes in the electrolyte, okay, we'll just have two examples or two cases right there. So the first one, okay, in case of water is decomposed, okay, then you will find that concentration will decrease. So let's see the first example. So example one, okay, we have dilute sulphuric acid. So we got sulphuric acid. And then we know that in the process, H plus will discharge, and hydroxide and sulfate ion, hydroxide ion will also preferentially discharge because of a high position in ECS. So in this case, you find that water is consumed. Water is decomposed. So less water, the concentration will then be higher. Okay, so the second example will be very more or less is the same. So you find it with water with sodium chloride. As this one is very dilute, so you will find that in the process H plus and hydroxide ion will discharge. So again, the concentration of the sodium chloride will also increase. In some cases, we found that the chemical will consume instead of the water. Okay, so in this case, we can have a look. For the first one, we have like conc NaCl. So we got NaCl, H plus and OH minus. As we are using mercury as electrode, Na plus will discharge, and because it is a concentrated, so chloride ion will be discharged. So in this case, you'll find that the concentration of the sodium chloride will then decrease. While the other one, okay, we are having concentrated copper 2 chloride. So for this one, okay, we will know that Cu2 plus will discharge because it is a lower position in ECS than H plus. It is stronger away. While the other one, it is a concentrated effect again. So chloride ion will be discharged. So in this case, we'll find that the concentration of the copper 2 chloride will also decrease. So these are some of the examples talking about the changes in concentration. Okay, when water is decomposed or when the chemical is consumed during the electrolysis. The other cases is talking about the nature of electrolyte will change. So for example, the first one, okay, we have like concentrated sodium chloride, and then we are using graphite as electrode. So if we are using graphite as electrode, you find that in this case H plus will discharge because Na plus is very weak away, or while the other side, because it's a concentrate, so chloride ion will be discharged. So by looking at the ion table, you will find that the solution from sodium chloride will then become sodium hydroxide because we just have sodium hydroxide ion leaving behind. Okay, so therefore the nature of the electrolyte will change from a neutral solutions become acidic. So you'll find that acidic is alkaline. So you find that in the process, okay, the nature of the electrolyte will change. While the other one, okay, you find out we'll have a like copper 2 sulphate ion. So for copper 2 sulphate ion, so Cu2 plus will discharge, hydroxide ion will discharge. So this time, okay, it changed from copper 2 sulphate and then become sulphuric acid. Okay, so you'll find that again, okay, it changed from a neutral solution, but this time it changed to acidic. So in some cases, you find that the solutions after electrolysis, the nature of the electrolyte will also changes. So this one, okay, is a table that you can find in your textbook, but I just want to draw your attention to some part, okay, so pay attention to that. So first of all, okay, I'd like you to have a look of the changes of electrolyte. So this one you can using the ion table to help yourselves, okay, to find out whether you can find it like concentrate, dilute, become alkaline, or become acid, things like that. Okay, this one should be quite easy. Okay, but the other things I want you to pay attention to, okay, will be the this part. Okay, very dilute, could be called O2 discharge. Concentrate, we have chlorine. But one thing you didn't see that, okay, we don't have mentioned anything about like dilute sodium chloride. It is somewhere in middle, like 1M to 2M, things like that. So if it is in a dilute case, so whether they will give out O2 or Cl2. So in this case, you have to bear in mind, okay, they will both produce or in the process. Cl2, okay, will be a minor product, while the O2 will be the major product. Because at the beginning, okay, the chloride ion is a little bit more than very dilute, but it is not concentrate. So only some of the chloride ion will be able to discharge and give out chlorine. But mainly, okay, still the hydroxide ion to discharge to give O2. So this one, okay, it is mentioned in this table. I just want you to remember of that. Or the other things, okay, is about the special electrode that we have used. If we use a mercury cathode, you find that, okay, sodium will be produced. Okay, so actually after the sodium produced, or you should remember, after the sodium produced, they will combine with the mercury to form sodium amalgam. Okay, while the second case is, okay, it will be like using copper as the anode, okay, and then they will generate Cu2 plus. So if you remember in that cases, okay, we'll have like Cu2 plus, H plus, SO4 2 minus, OH minus, and also Cu. So in that case, you find that Cu2 plus will discharge, while Cu will keep on releasing Cu2 plus. So the concentration of the Cu2 plus, more or less, they are the same. So you find that, okay, in this case, there's no changes in the solution. Okay, so other than that, okay, I'd like you to draw attention to this area. So the first one will be, let me see. So the first one, okay, will be graphite, oxygen, graphite, oxygen, graphite. Okay, not this one. So pay attention, okay, graphite and oxygen, actually they are not a good match, okay, because we got graphite, which is carbon, we got oxygen. When they produce oxygens, okay, the carbon and oxygen, they react to form CO2. So in the process, okay, the graphite will be broken into pieces, okay, broken into pieces. So in this case, it is not a good match, okay. Other than that, second things that you have to pay attention to will be the chlorine, okay. But for chlorine, okay, in this case, still use graphite, it's okay. But in some cases, if we use platinum, then that will not be good, okay. So next sections, okay, it will be talking about the mismatch, okay. Just now mentioned graphite, okay, with no match with, not a good match with O2, okay, because we find that the graphite will react with the oxygen to form CO2. So the graphite will be broken into pieces. So in this case, if you really have oxygen form in the electrode, so you can change to use platinum. While the other one, platinum, they have no good match with chlorine, because chlorine will attack platinum. So if you have chlorine produced, then you can change to use graphite for the electrode. So these two are commonly asked in the DSE about the mismatch of the electrode. So in short, okay, we're going to have a conclusions. So when we talk about changes in electrolyte, okay, you have to pay attention to the ion table, cross out the reacted ions and then see what kind of ions remains. Okay, so the changes in the electrolyte mainly talk about changes in the concentration, like concentrate or dilute, or even the nature of the electrodes. The electrolyte will change. But do remember, in these cases, never mentions the volume of the solution decrease. Even the water is getting less, but it is not good enough to say that volume of a solution decrease, because maybe the observation is not easier to see, But in some cases, you really can't think any about the changes in the electrolyte. You may move on. For example, when you talk about molten electrolyte, say when you have Na plus Cl minus only. In this case, the Na plus discharge, chloride ion discharge, you get less and less the molten sodium chloride. So in that case, you may say that the volume of the liquid decreases. Okay, so that's all for this video. Bye bye.